We'll begin the chapter by looking into something called a centripetal force. To understand centripetal force, we need to recall uniform circular motion. Guys, you have studied this. So what is uniform about uniform circular motion? What does the word uniform relate to here? Yes, constant speed, is it not? And next thing is circular motion. That is, the object is moving in a circular manner. Actually, it takes a circular path. That would be a better phrase. It takes a circular path. Now, on this, I have few questions which will help us understand centripetal force. The first question being, is the speed changing? An object in a uniform circular motion, is its speed changing? Clearly no. That's the whole idea behind uniform circular motion. So answer is no over here. Is the direction changing? This you guys have to think. Yes or no? Well, it is yes. Why? Quite simple. Here at this point, right, in this diagram, the object is moving in this direction, whatever I'm pointing towards. And when it comes, say, over here, at this point, right, it would be moving in this direction. Make sense? If not, we'll be understanding this in detail. So answer over here is yes, it's changing all throughout. Does it require force for such a motion? Do we require force for any object moving in this manner? Answer is yes again. Can you justify this? See, this particular object is accelerating. What does accelerating mean? Well, let me write that. Accelerating. So what does accelerating mean? That is changing velocity. But speed is constant. Why is that I'm telling it's changing the velocity? Because velocity is a vector quantity. That is, it has magnitude, in this case the speed, and it has direction. And since the direction is changing throughout, it's an accelerated motion. And so as per for the formula F is equal to ma, any object that is accelerated need to have some force acting on it, right? So let me summarize. We have an object moving in circular manner, circular path. In this particular case, we have just taken uniform circular motion because your syllabus talks about it. So for this object to move in a circular path, it needs to have a force that is acting throughout. If there was no force, it won't be taking a circular path. Okay. So what is the literal meaning of centripetal? Center seeking. Now you guys understood how is all of this related? So centripetal force is a center seeking force that makes an object move in circular path. Understood? So if I want to show it in a set manner, that is in this manner. In maths we have some topic called as sets. So it's a visual representation of things, categories. So if all of this are your different kinds of forces, right, centripetal force is one of it. It's a force. It's a specific, the nature of this particular force is specific. So it's given a separate category, right? That's it. So what does this force do? It will make an object go in a circular path. As simple as that. Good? Okay. So now we have an experiment. The main aim is to understand your centripetal force. The procedure is quite simple. We rotate a ball attached to a thread and let it go. So basically you attach a bob or a ball, you turn it around and let it go. So what is that we need to observe? The direction of motion of the ball after the release and also the point of the release. Right? You will understand this as when you see the video. Repeat the above steps by letting go the ball at different points of release. So it's easy, something that you guys can do as of now itself. You can tie a thread with a pen or a pencil and be careful that there's no one around so that it won't poke or hit. So you guys can do that. But yeah, before that you guys can watch this video so that you get an idea about what is it you're trying to understand and look at. Okay, you guys got a good idea. So what is that we observed? I had 3 examples. I'm just showing 2 of it. So I was moving an object, a bob, in a circular manner, and at this point I let it go. What happened? The bob, it took a path, a straight path, and this line happened to be a tangent. Remember tangent? I taught initially. Tangent is a line which touches the circle. Right, let me show this. Which touches the circle at a single point. Okay, so here in the second example, I released it somewhere over here, and you can see it's taking a tangential path. And the third example, I released it over here, and there also it took a tangential path. Okay, again, we are making an object move in a circular path. And if we release the object at any particular point along this path, a general conception would be that it will go something like this, it will go something like this, and we don't see to that extent, but yeah, I'm sure you guys would have not thought of it, what will happen to that. You guys would have been like, it might take some curve path because of its previous motion. It won't take a curve path, it will take a straight path. The curve nature comes because of gravity. Right? Okay, we'll not go to that. You will get confused. As of now, we are trying to understand one key point, that is, the ball takes dashed path when let go. Clearly, it takes a tangential path. Tangential path. Right? So what can we conclude? A continuous force dash required for an object to move in a circular path. Do we need a force for an object to move in a circular path? Yes, we need a continuous path, right, for an object moving in circular manner. So the direction of velocity is always tangential to the path of the object. Don't worry, you guys will make sense of all of this as and when you study the chapter. So direction of velocity is always tangential to the path of the object. That's why this bob, when we released, it took a tangential path, right? Because the velocity is in that direction at that moment of time. If I had released over here, all I have to do is I need to draw a tangent and you're done. As simple as that. Right? If the bob is going in a, this is circular, right? This is, yeah, clockwise, not circular. I meant to say clockwise. So it will go over here. If it was anti-clockwise, it would have gone this direction. Okay, so it will be tangential, but end of it would be tangential. That is, once the centripetal force disappears in the sense when I let go, right, I stopped applying the centripetal force. The object moves along the tangential direction. You saw that. Tangent to the circle at the point of release. Tangent to what? To the circle in which the object was moving in. All this is well and good, but the big question is, why is that we are studying centripetal force in gravity? Right, the heading is gravity. I mean, it's common sense to start off any topic with the heading of the chapter, is it not? But the very first topic is centripetal force. Why is that we are studying this? Why not directly the gravity part? We'll be understanding this in the next video, right? So you guys have to make a note of, again, you have to make your running notes. So you can pause and have a look over here. And these two definitions you guys have to write. Experiment, the procedure and all, you just make a running note. Of course, this will come as an MCQ question, reason based question, and all of that. So you guys have to be prepared. That's why it's better to write a small running note so that you guys make sense out of what you just studied. Again, diagrams, if you guys can draw, it would be a lot helpful than just writing theory. Visual always helps, right? You guys can see the difference. This is a simple video, but yeah, with applying the technical aspect, it makes sense of what we are studying. And a picture helps a lot to make you guys understand. And it's the same when you're revising, it's trying, you guys are trying to communicate what you understood at this moment to the future you. You are helping your future you to understand a concept which you have understood as of now. Okay, so I hope I have given enough tips or encouraging points for you guys to make running notes.